Let's try problem 10.52. A 20 kilogram child is on a swing that hangs from a 3-meter long chain, as shown in the figure. What is her speed v at the bottom of the arc if she swings out to a 45-degree angle before reversing direction? Okay, so this is just going to be another energy problem right here. So we have some kind of kinetic energy right here, and we're going to call this position right here h is equal to 0. And so at this point right here at the bottom, there's not going to be any potential energy. And as she swings up, she's going to lose kinetic energy, right? Because she's slowing down, to eventually she stops at the highest point. And this is going to be some distance up. So we'll call this h1. And then also at this point, she's going to have a velocity equal to 0, right? Because she's not moving anymore. She's not going to have all of her kinetic energy at this point. It's going to be transferred over into potential energy. So the first thing to do, we need to find is this h1 right here. And so we know this angle, and we know the length of this chain, which is going to be 3 meters. So to find this side, all we have to do is just do the cosine, right? Because cosine is adjacent over hypotenuse. And so the cosine of 45 is going to be equal to the adjacent. We'll call this actually h1 over 3 meters, which is the hypotenuse. Right? So I'm making this triangle right here. So this is one side of my triangle, this is going to be the other side of the triangle, this is going to be a third side of the triangle. And this side right here is going to be 3 meters, right? Because that's the length of the chain. And we're trying to find this h1, this distance from the top to right here. And so it turns out h1 is going to be equal to 2.12 meters. And so that's the distance from here down to here. Let me change colors to make this more clear. So it's going to be distance from here to here. But we're not interested in distance. We're interested in distance from here, from this bottom, up to here. So we know this is 2.12. So all I have to do is 3 meters minus 2.12 meters. This is going to be equal to 0.88 meters. So now we have the distance from the bottom to our max height right here, and that's going to be 0.88 meters. So 0.88. Okay, so now let's calculate her potential energy up at this point over here. So potential energy, we'll call it U, is going to be equal to her mass times the gravity times that height, which we just found out to be 0.88 meters. So then we know that the potential energy at this point has to be transferred completely back into kinetic energy at this point. And so we know that this potential energy right here has to be equal to the kinetic energy at this point down here, right? Because when she gets up to this point right here, she has no kinetic energy at all. It's all potential energy. And when she's down here, it's all kinetic energy, and there's no potential energy. And it's a closed system, right? So the energies at both points have to be the same. So we can say that the potential energy has to be equal to the kinetic energy. Potential energy at the top has to be equal to the kinetic energy at the bottom. And so we just do. And so rearranging this is equal to 1/2 mv squared. And so just solving here, our m's are going to divide out. And so multiply 2 to both sides, and we get 2 times g times 0.88 meters is equal to v squared. And so v is equal to the square root of 2 times g times 0.88 meters. And when you plug this into your calculator, this comes out to 4.2 meters per second. So that's the speed that she's going to have at the bottom right here. And that's problem 10.52.